Good afternoon, all.
Good afternoon, sir.
Am I audible?
Yes, sir, you are audible. मुझे तो audible है आप.
Okay. Okay. So we are starting the graph representation. In previous lectures, we have initiated the graph unit, last unit of the data structures and algorithm, that is graph, and we have learned something, some basic terms of the graph, and we have also started the representation of graph. So two types of the representations are there, that are static and dynamic representation. So can static representation includes two kinds of matrices, that is adjacency and incidence matrix, that I think we have covered.
Yes, sir, you have covered. You are covered.
So adjacency matrix and incidence matrix, can anybody tell me what is adjacency matrix? What could be a adjacency matrix of a graph of n vertex? Yes,
Sir, n by n.
n by n matrix will be very good, and it will be in the vertex to vertex only.
Square matrix.
So 1 by 1 n by n matrix is there, and if there is an edge between the two vertices, then we will say it is 1, otherwise it will be 0. And what about incidence matrix?
Sir, it is
Sir,
a
it is
relation
in the
between
order
the
of
vertex and edge.
Sorry,
It is the order of vertex and edges.
it is the order of vertex cross edges. It means the number of vertices cross with number of edges. So n cross e will be the order of this matrix. Okay, and here we will see that particular edge is incidenting on that vertex or not. If it is, then it will be 1, and otherwise it will be 0. So that is what the incidence matrix we have seen. We have seen for both directed and indirected graph. Now we are coming on to the linked representation of the graph. Linked representation, it will be definitely a dynamic kind of representation, and for that again we required some adjacency list of the graph. Okay, it will be useful when adjacency matrix is sparse for a graph. So can anybody tell me what does it sparse means? Sparse matrix means the most of the entries of the matrix are 0. Like in the case of, I have discussed, I think,
Null matrix.
Not even a null matrix, actually most of the entries are 0, actually I am saying. Okay, most of the entries. So like suppose we have discussed a graph also in which only the loops are there, and in that case only diagonal matrix will be created 1 1 1, and rest all the entries are 0. We have seen that, yes or no?
Yes, sir.
In that case we can say that that matrix is a sparse matrix, because most of the entries of that matrices are 0 actually. So in these specific cases, what we can do is we can use the linked representations in order to like we can say save space. Okay, so what we need to do is in this representation we have to maintain the list of each vertex, and then for each vertex the adjacency vertices of that specific vertex actually. Ultimately, that is adjacency vertex list we will maintain, and that's why this particular representation is also known as adjacency list representation. Okay, so linked representation is also called adjacency list representation. So for this specific graph, I have already made a adjacency list. Is it okay to you all? That we have already discussed, I think, in the previous lecture. So adjacency list is the list of vertices which are adjacent to the specific vertex. Like for A here, C is adjacent only. For B here, A is adjacent only. For C, it is B, D, and E. All other three vertices are adjacent, and so on. Is it okay to you all? Is this
Yes, sir.
Yes, sir.
adjacency list is clear?
पड़ोसी.
Okay. So now what we will do is actually look at that. This is a given graph to me. How we will make the linked representation of this particular graph. This is important, actually you need to understand carefully. This is adjacency list representation of the graph. So with the help of that table, we have identified that for A, C is the only adjacent vertex. Okay, so we have started with this. Okay, and now in this you can see this particular part, first we can say a list. This is the list of, can anybody tell me, this is the list of vertices
Vertices.
of the graph, and
Sir,
this is the list of,
Edges.
you can say, the edges of the graph, like
adjacent
from A to
nodes.
C there. Sorry, adjacent nodes. Yes, you can say adjacent nodes, and adjacent nodes means key edges. Like from A to C there is an edge, from B to A there is an edge, from C to B, then C to D, and then C to E there are edges. Similarly, from D to A and D to D there is an edge, and from E to B and E to D there is an edge. So this particular list is known as vertex list, and this is known as edge list actually. So adjacency list will be the combination of, when we are going to represent a graph using adjacency list, it will be containing two lists actually. First one is vertex list and second one is edges list. Is it okay? First, learn how it will be actually done actually. Properly we will see how it will be done.
We are represent graph this time in link representation this.
No, we will modify it also. This is the very, like, this is only the adjacency list representation. This is not the linked representation of the graph. Okay. This is adjacency list representation. I have written in the, like, below the diagram. This is adjacency list representation of the graph. Now,
Okay.
now look at that. This is vertex. Okay, so how this vertex will be represented as a linked node, and this is an edge. So how this edge will be represented into a node form. So this there here it is. Actually, vertices are represented using a node of three parts. So whatever the vertices we have in this, that is A, B, C, D, E, all these vertices will be represented using a node that has three parts. First part of that node will be vertex name. Second part will be the next vertex link, and third part will be the edge link. Okay, so here what we can say that A. So for A, how it will be actually, look at that. For the vertex A, three parts should be there. Okay, a node for with three parts will be there to represent that particular vertex A only. Okay, so in linked list representation, first part will be the node itself, A, vertex name, that is A. Then is next vertex link. So next vertex that is linked to A is B in this case. That is the next vertex which is linked. So here we will write the B. It could be any. Actually now it is random actually. You can take A.
So it could be D.
Yes, it could be D also. So whatever the order you are following, it should be like this. So the next vertex that you are linking to A will be there in this part, in this node part. Okay. So now next one is the edge link. Now edges that are connected to A. So A से निकलने वाली edges कितनी है? AC. So here we will make a link of that edge actually. Okay, so here you can say that link address will be there. Like this one is there, na? So AC is there. So यहाँ पर एक edge list आएगी अब, जिससे through linked over. So first of all, it is okay to you all how a node is being represented using how a vertex will be represented using a node in this linked representation. Next one is edges will also be
Sir?
representing using a node. Yes.
So next vertex link can be many, na, for a single vertex.
No. Actually, this could be a linked list only. A, B, C, D, E. आप समझ सकते हैं कि it could be a linked list only. So A, B, C, D, E. Linked list का मतलब क्या होगा कि one after another. It will be a linear representation only. It will not be a non-linear representation. In the case of non-linear, it could be many, but in the case of linear, it should be only one that is connected to the first one. Are you getting it?
So we are trying to make a linear representation.
Definitely. Linked representation means linear representation. Linked list is the,
But graph is non-linear.
हाँ, तो
Yes,
ट्री में
sir.
भी, ट्री में भी हमने देखा था बेटा, ट्री में भी लिंक्ड लिस्ट रिप्रेजेंटेशन देखी थी. Have you remember that?
यस सर 1D एरे से कर रहे थे उसको.
1D एरे से कर रहे थे, वो तो एरे रिप्रेजेंटेशन था. लिंक्ड रिप्रेजेंटेशन भी देखा था हमने.
Yes, sir.
यस सर देखा था.
तो उसमें भी बेटा हमने ट्री थोड़ी बनाया था. We have used a linked list and like that linked list will be, उसमें दो तीन एरे थे, तो नोड था, लेफ्ट था और राइट था. तो
यस सर डाटा
सिमिलरली
पार्ट.
तो सर जैसे तो सर जो भी हम रिप्रेजेंटेशन लिंक रिप्रेजेंटेशन कर रहे हैं तो हम इसको सीक्वेंशियली करेंगे ना, मतलब एक को अगर हम बी से कर रहे हैं तो
डेफिनेटली,
अगर हम बी नोट बनाते हैं तो उसको सी से करेंगे कनेक्ट.
हाँ डेफिनेटली, definitely है ना. That will, this vertex list that I am going to show you, it will be a linked representation now. You will see how. So यहाँ पर क्या होगा, like B, what does it B means? It means का address of B. तो एक लिंक होगा यहाँ पर जिसमें B नोड का एड्रेस स्टोर होगा. Here it will be B, and then it will contain the address of next node, that is C say. So it will be C and so on. This is a linked list or not?
Yes, it is linked list.
This is a linked list with containing two pointers actually. One is data value and two pointers are there. So is it
Address
okay?
card.
Yes, sir.
So that is what the linked representation will be. So now edges will also be able to represent with the help of a node, but in that case two parts only there in that node. One is adjacent vertex link and next edge link. Here you can see that adjacent, we have used the term adjacent. So here only adjacent vertices could be there. Okay, like for A there is only one adjacent, so it could have only one adjacent. Okay, but if I am having multiple adjacents, like in the case of C, so it could be either B, B or E also. तीनों में से कोई भी हो सकता है. So adjacent vertex होंगे यहाँ पर next vertex है, तो ये this is different. Okay, so now here the next edge link. So in this we will have a next edge. Like now we will see for that. Okay, so E, this is an edge. So edge is represented by two part. So like जैसे हम इसी की बात कर रहे हैं, A की. So इसमें क्या है, यहाँ क्या आएगा? First of all, adjacent vertex link. तो adjacent vertex to A is, A का adjacent vertex क्या है?
C.
C. So link of adjacent vertex. Okay, link of adjacent vertex you can say. And now the next adjacent vertex link, next edge link. तो कोई और adjacent vertex है क्या A का? नहीं, तो ये null हो जाएगा ultimately. ठीक है? For let us say for C we will do. Okay, suppose हम C के लिए बनाते हैं, तो C node is there. Okay, C के लिए edge list. तो C के adjacent vertex, what are the adjacent vertex of C?
E.
It could be B, it could be
D,
E, it
D
could
and
be
E.
D. So now I can take anyone. First vertex that is adjacent to, I can take anyone. Let us say I am taking D. So D. Then next one is, next edge link is B, say. Okay. And then next edge will be E, say. Is it okay? And then next edge is null actually. There is nothing. So three adjacents are there for C. So this is adjacent vertex link and this is the next edge link. Is it clear to all now?
Sir, can you see?
Sorry. Please speak again.
Repeat again.
Okay, let us
The
see
voice
the
is
whole diagram
dim.
of that. Let us see the whole diagram of the same. Okay, that is what the linked list representation now. That is the final linked list representation of the graph. जो मैंने यहाँ बनाया है, that is finally we have drawn over there. Look at that. So first of all, this one is vertex list and this one is edge list. Okay, now vertices are first of all connected to each other through a linked list. Look at that part only. So we are starting with say A. हमने अभी alphabetical order में लिया है, तो A B C D E. So according to this representation, vertex name is there, next vertex link will be there and edge link will be there. So vertex A is there, then next vertex is B. So the link of B is there. Then in B we have the link of C. Then C we have the link of D, and in D we have the link of E. Finally, it is null because after that there is no vertex. This is null. So till that it is. हाँ बोलो. आप कुछ बोल रहे थे बेटा?
नहीं सर, आप पहले फिनिश कर दो.
So is it okay to you all? This is vertex list.
सर मुझे ओके नहीं है सर. ये सर एक तरह से नेस्ट बन रहा है सर. मुझे कौन कहाँ जा रहा है सर?
अभी मैंने केवल ये पूछा है कि ये क्लियर है क्या? आप सुन तो रहे नहीं हो बेटा? This particular vertex list is clear बेटा? ये I am asking that.
Yes sir, vertex list तो क्लियर है, लेकिन ये लिंक पार्ट सर क्लियर.
ये मैंने बताया ही नहीं अभी आपको. ये मैंने बताया ही नहीं अभी तक आपको. Look at that now. I can take a new and then I can try to make it for you at that time. Look at that. First of all, we will make a vertex list. So vertex list के लिए क्या होगा? This is A. Okay. Next vertex will be. You all tell me now. Next vertex will be
C.
It could be C. Okay. Next vertex could be. You can take it any order now. No issue in that. I don't have any issue.
D.
It could be B.
E.
It could be. Then it could be D, as you are saying. Then finally it could be
E.
E. Okay. Now this part of the node A will hold the address of next vertex, which is C. So ये इसका part हो गया. Okay. This will hold the address of next vertex, that will be holding the address of B. This will be holding the address of next vertex, that is D. Okay. And this will be holding the address of next vertex, that is E. And this will be holding null because after that there is no vertex we have in this graph.
Sir, as we are showing the connection between A to C, C to B, sir, there must be a connection between these, or there must be adjacency between these.
That adjacency relationship we will show in the edge list. Till now,
No, sir, we are just showing a direct connection between all these vertices.
Yes,
there
yes.
should not be a adjacency between all these, because there is no adjacency between D or
No,
E.
no. We are not showing here the adjacency.
Okay, sir.
Here we are not showing the adjacency. Here we are just having like 5 vertices. Suppose I am having 5 values we are having, and I am creating a linked list of that. Randomly I am taking the elements, I am creating a linked list of them.
So is it compulsory to arrange them in a certain order? We can take a C also first and then A, B, D in such case?
Definitely. वो कोई मैटर नहीं कर. लाइक यहाँ पर देखो A B C D E लिखा हुआ है. मैंने यहाँ पर A
Yes,
C
sir.
B D E कुछ अलग ऑर्डर लिया है.
Okay, sir. Okay.
Now order matters here actually. Okay. So now A के बाद adjacency कौन है? अब edge list बनेगी actually. Okay. So
Sir, C.
this pointer will contain the address of that edge node that is there from A to the other vertex. So A के adjacent कौन है?
C.
C. So we will make a node for that edge. This is edge list now. So A C के लिए हम बना रहे हैं अब एक node. Okay. So adjacent vertex is C. For A I am saying. So this is where that is. Okay. So adjacent vertex list. So C कहाँ है इस वक्त? ये क्या hold करेगा? Address of C actually. Is it okay? So A to C there is an edge which shows that C is an adjacent to A actually. So this will hold the address of C. So now this particular connection will be there. C node का address यहाँ आएगा actually. Okay, and which shows me कि from A to C there is a edge. Is it okay? It will not hold the value C, it will hold the address of C actually.
Sir, can you write the star C?
Yes,
Yes,
sir.
it could be a start C. Like C तो मैं यहाँ लिख रहा हूँ, actually it will hold the address. So for your understanding, I am putting star over there.
Sir,
Okay.
he is already connected to D, B and D and B or
Now C. अब हम देखेंगे C के adjacent कौन है?
D or
B, E
or
and D.
B or E.
Three nodes are there, that is B, D and E. Okay, so I am taking first one, that is B. Say suppose B. It could be D also, no issue in that. So from that I have a edge, from C I have a edge to B. Okay, so address of here B. So it will be pointing to this node. And any other adjacent vertex is there?
D.
D.
D and E.
So next, so look at that. Next edge link. Okay. So adjacent vertex link and next edge link. So next edge could be C2. Which one I will take? You just tell me.
E.
C2.
B we have taken, so we can take E. As someone is saying E, so E is there.
Sir, is there a pattern we should follow clockwise, anti-clockwise to
No,
go to
not at all. We can take
randomly, right?
yes. We have three vertices. You can write it in any order. Okay. So now it is B. So हमने E लिया यहाँ पर. So E का address यहाँ आएगा actually. Address of E actually. Star of E लिखा था. E और star लिखना है. और यहाँ पर क्या आएगा? इसका लिंक. Next edge का लिंक. तो E कहाँ है अब? E है हमारे पास यहाँ पर. Is it okay? And then there is a D. So D H एक और बनेगी यहाँ पर. So address of D. Okay. Now D का लिंक आएगा यहाँ पर. And this will be null now. Similarly,
So
this
sir,
will
the
also,
edge links node next always be null.
sorry.
Edge links node, sir, the node which is showing our edge link, the next of that will always be null. The last of which we are seeing.
Definitely, if no other adjacent vertex is there, so it will be null.
Okay.
Like
Sir.
in this case, it is not null. Actually, it is pointing to E. It
E,
is
yes sir,
pointing
yes
to-
sir.
It is
The
pointing
last
to
one,
D.
the last one will always be null.
Definitely will null, because there is. It shows that now there is no adjacent vertex to C. So इससे क्या मतलब निकला? देखो, C के adjacent कौन कौन है? B है, C के adjacent E है, C के adjacent D है. So I can move from C to B, D and E. So now with the help of these edges I am moving actually. Now see that. From A to C I can move. Okay, यहाँ पर हमने देखा A to C गए. इस डायरेक्शन में देखिएगा, मैं इसको ब्लैक से रिप्रेजेंट कर देता हूँ. Like from A to C I can go. Then C is there. So C से I can go to B. Then from C2 I can go to E also. Okay, and then from C2 I can go to D also. So ultimately B, D and C, B, D and E are also reachable from A. AC भी reachable है. But through C
So
we can
what-
go from them. Yes, ask.
So the connection between B and E and E and D, what does it tell?
Okay, these are telling me that these are the other vertices that are adjacent to C.
So then it should be directly connected to C.
No, like अब आप देख रहे हो, हाँ वो चीज अलग है. But edges list we are maintaining actually over there. So edges list mean कि CB is an edge, CE is an edge, and CD is there is an edge.
नहीं सर, जैसे अभी you are telling कि we can move from C to B, C to E and C to D, but we are not moving
Yes.
directly ना.
Directly, but we have a list of that vertices जो उसके adjacent हैं, B, C and D.
So sir, for direct connection we need to have
and
more
ये are
than
adjacent.
two
हाँ,
pointers.
तो direct connection होना चाहिए ना.
हाँ, you are मतलब उस theoretical point of view से आप सही हो, लेकिन now think over that how you can represent that into the linked list.
We should have more pointers for direct connection because to save the address of E, D, and B combinedly in C.
So how you can identify the total number of pointers for that?
As much have the number of E have edge links, then that much only pointers we need to include in C.
So this will not be actually a perfect one because
Possible, yes, sir. That won't be possible, sir.
for this small graph it is possible, but actually in our real life situation the graphs are not so small. If you compare it with the Google Maps, say, so can we do it? Can we identify that how many pointers we can have? We should have for the vertex, and to find out the adjacent vertices.
Sir,
So
I
we are
will.
actually we are trying to reduce the burden, and हम क्या कर रहे हैं कि एक जो भी adjacent list है उसको maintain कर रहे हैं एक linked list में. This is again a kind of a linked list, you can say. ये भी तो एक linked list ही है ना?
Hello, sir. I
Yes.
have give some idea that if we create a structure of the graph link presentation,
Explain.
then if declare many pointers, then a vertices also contain many pointers, but not relationship between a to d, a to e, and c. It is easy for c, but all vertices not contain connectivity with D, B, A, S this type. So it is not wise idea that we declare many pointers.
Okay. Uh, anybody wants to say anything? Or ask anything? This is the list also. This is a edge list. I have already explained that this is a edge list. So two linked lists
So,
we
sir,
are like multiple linked lists. Yes.
so we have shown the
Yes.
connection of the edges with B and E, but indirectly we can say that these are directly connected to C.
Yes. Indirectly, we are saying that these are directly connected to C actually. Actually, this is an edge list for C actually. This is an edge list for C. Specifically, if I will told ki I will like tell you ki that this is a edge list for C. ये edge list है. So from C where I can go to B, I can go to C, I can go to D. This is an edge list for C actually. Similarly, we will have
Yes, sir.
a B. For B, I am having an adjacent vertex as
A.
A. So I will make a node which contains the address of A first of all. It means kind of connection in this type. Okay, and here it will be null. Any doubt you have? For D, it will be how many nodes are adjacent to D?
E and A.
D and A. So here I am getting a connection of D itself. So D will be pointing to D only, and one more connection for the A. It will be look like this. Okay, and for E it will be B and D. Two vertices are all there. B and D. Is it okay? This is the whole linked list representation of your graph. And it is representing in this diagram only. This is the final diagram that I have simply like pasted for you. Is it okay now?
सर उसको जो आपने प्रीवियर और आपने जो बनाया था उसको बने रहने देना सर, उससे समझ में आ रहा था.
First time when I have studied this one, the same thing came in my mind. Why I have not a direct connection between C to B, C to E, and C to D. That is what obvious. So now the point is clear to you all or not? Say yes or no at least. If no to no.
Yes, sir. Point is clear.
Yes, sir.
Should it is okay? Should I move to the next topic? These are the representation of our graph. So 3 representations we have seen. First one is static representation, which includes 2, that is adjacency matrix and incidence matrix. And second representation we have seen as a linked list representation, which includes the adjacency list form. And that is all about the representation of the graph. And now I am moving on to the traversing of the graph. Should I, or you have any question? No question at all? So I am moving on to the next topic, that is graph traversal. What do you mean by a traversal?
One after the other.
What is it? What is traversal? Traversal means ki accessing each node of the data structures exactly once. So how many kind of traversals are there for the tree?
2 types.
3.
Okay, name them 2 types of the traversals. For tree, I am asking how many traversals we have studied. You have said 2, then name them 2 traversals. So name the traversals. Anybody else? कितनी traversals पढ़ी थी हमने?
3 pre-order traversal, post-order traversal, and in-order traversal.
So now here we will study the traversals of the graphs. Okay. So graph traversal means visiting all the vertices of the graphs. There are 2 types of the traversals we will learn for the graph. The first one is breadth first search and second one is depth first search. It is also known as BFS and DFS in short. Okay. First of all, coming on to the breadth first search. So breadth first search algorithm traverse the graph in breadthward motion. Breadth-wise nodes traversal होंगी इसमें. Okay. We will see how. Now it uses a queue to remember to get the next vertex to start a search. It means the data structures we will use in this is queue. Okay, queue we will use in this. Next vertex to start a search when the dead end occurs in the iteration. So queue will be used to hold the vertices in between our calculations. Some rules that we are going to follow in the breadth first search is, first of all, we need to start from the first vertex that will be that should be given to us in our question, or we can take it at random also if it is not given to us. Okay, one vertex we need to choose for starting our traversal. So and then visit the adjacent unvisited vertex. Underline the word unvisited. So we will pick the adjacent vertices which are already not visited and then mark it as visited vertex. जो हमने pick किया था vertex उसको हम visited mark करेंगे and then display करेंगे और then उसको queue में insert कर देंगे. Okay. And if suppose there is no adjacent vertex found, किसी vertex से जरूरी नहीं कि हर vertex का adjacent vertex हो, so it could be a dead end to us, or we have a vertex with no adjacent also, and then we will remove the vertex from the queue. Okay, which I have already been into the queue actually. And then we will, this same process will be repeat till queues will not be empty. So let me take an example first, and then we will write the algorithm. Suppose this is a graph given to us. So first of all, is it directed or undirected graph?
Undirected.
Undirected graph.
Okay, so first of all, I am going to find out the adjacent vertex list of that graph. So I have deliberately put blank over there. So you just tell me what are the adjacent vertices of A. I have listed all the vertices over there, A, B, C, D, E, F, G, H. Now I am going to make a list of the vertices which are adjacent to the list node A. So tell me what are the adjacent vertices of this.
BCD.
For A it will be B, C and B. For B it will be
FCE.
C.
CAFE.
C, F, A.
CFA.
Yes.
E also.
E also.
E also, sir.
Okay, very good. So A, C,
अरे हाँ.
F, A. ACF, E.
E,
E.
Okay. Or next is C. So for adjacent vertices of C will be
D,
B, D,
A,
F,
E,
G, E.
G
A.
और F.
A, B,
A, B, D.
E, D, G.
A, B, D. F, E,
G,
G. F, E,
G.
G.
now for D.
C, G, E, A.
A, C, D. A, C, E, G.
For E.
B, D, C, F, G. B, C,
For F.
Yes, sir.
G, F, C,
B, C,
E,
E.
B.
For F, B, C, E.
And H.
H
Is also
also.
there. For G.
H, D, C, E.
CEDH.
F, G. Done.
First task for us in the breadth first search, we need to find out the adjacent vertex list. So it is okay to you all now? Till that point it is okay?
Sir, can
Yes,
you
sir.
tell me what is breadth for search? For मतलब क्या होता है सर ये मतलब कुछ ऊपर से आइडिया सर.
वही पढ़ रहे हैं बेटा अभी हम, केवल आपको नहीं सभी को पढ़ा रहा हूँ वही चीज है ना बच्चे. ब्रेथ फर्स्ट सर्च ट्रैवर्सल मेथड है ग्राफ का. ट्रैवर्स करेंगे हम वर्टेक्स को. ट्रैवर्सल क्या होता है पता है आपको?
यस सर.
तो बस ट्रैवर्सल करने वाले हैं बेटा हम ग्राफ का, है ना. एक मेथड है BFS जिसके थ्रू हम ट्रैवर्सल करेंगे. Okay, so first of all we have identified the vertex adjacency list. Now what we will do is we will use a queue. Now everyone knows what is queue. So
Sir,
queue is based on which property?
LIFO. Last in.
First in,
First
first
in,
out.
First out.
First in,
LIFO
first
property.
out. Very good. First in, first out based queue is there. Okay, so we are starting with A. Right now, what I have assumed that A is my first vertex. Suppose it is given to me, or suppose it is not given, then you can take it any vertex for your choice of your choice. Okay. So for our convenience, I am taking A as a starting vertex. So first of all, I will add A to Q. First of all, I will add A to Q. Is it okay? And then position. This is the Q. That second column is shows us the position, position of Q actually. कि Q में क्या क्या है किस वक्त. Okay. So firstly, I have added A to Q. Okay. Now I will remove the vertex from the Q. So Q से कौन सा vertex remove होगा? अभी Q में यदि A है तो
A.
फ्रंट क्या हुआ और रियर क्या हुआ इस वक्त?
ए सेम होगा.
Yes.
0
दोनों
0
0 हुए and both are representing to A. So deletion भी A का ही होगा. So we remove A and now we will parallelly what we will do, we will add all the neighbors or the adjacents of A at the rear of the Q. So A has been removed and the neighbors of A, that is B, C, D, will be entered into the Q in any order. Now let me repeat, in any order actually. It could be B, C, D, it could be D, C, B, it could be C, D, B, whatever it is, whatever you want to take. Okay. Now in Q, how many elements I am having?
3.
3. And
3.
at the front, I am having
D.
front. On front, I am having B, and
B,
rear I am
B,
having
B.
D. Okay. And A traversal हो गया है graph में. As soon as we removed some vertex from the graph Q, it will be traverse. It will be treated as a traverse vertex. Okay. Now do it fast. Now what we will do, we will remove the another element from the Q. So which element will be removed now?
B.
B.
Which
And
is
now
at front end.
very good. It is at, because it is at front end. Now we will add. It means कि B process हो गया. Now we will add C, D, the neighbors of B, which are already unvisited, which are already not visited. You can say. Okay.
F and
So
D.
look at that. For B, the adjacent vertex list is A, C, F, and E. Okay. Now A has already been processed. C is already be in Q. So the remaining vertices are only F and E. Yes or no? So I will add F and E over there at the end of Q. It means rear. Is it okay?
Sir, but
Say
D
yes,
is
sir.
not the neighbor of B.
But it was the neighbor of A. That's why it is in this queue now. जो ऑलरेडी एलिमेंट्स हैं वो तो उसी में रहेंगे बेटा, हम नए ऐड करते जाएंगे इसके अंदर.
Okay, sir.
Okay. So is it okay now? We have removed A. One element at a time can be removed. Definitely we know that. Okay. तो हमने एक एलिमेंट को रिमूव किया, उसके एडजेसेंट्स को उसके अंदर पुट किया, देन अगेन सेकंड एलिमेंट को रिमूव किया, उसके एडजेसेंट्स को उसके संग ऐड कर दिया. But we need to be careful that the elements which have already been processed or which are already into the queue, they will not repeat it again. Is it okay? We will not repeat or revisit the vertex. हमें revisit नहीं करना है, because we know that in traversing we have to visit only once. Now what? We will remove. क्या remove करेंगे हम लोग?
C.
C.
C. Now C will be processed. Now C के बाद क्या रहेगा यहाँ पर?
G. D, E, F, G.
Okay. Now which element will be added to this? Because C has A, B, D, E, F, G. So which element is which is not visited till now? Only G.
G.
So we will add G in this. Okay. Now which will be removed now?
D.
D.
D
D,
will be removed. So very good. Then F, E, G.
G.
And which will be the adjacent of D now? D के adjacent हैं A, C, E, G. So is there any vertex which is not visited till now?
No.
So we will not add anything into the queue now. It is clear?
Yes, sir.
Now
Yes,
we will
sir.
remove. Now we will remove F. So it has only E and G, and
H also, sir.
adjacent of F. So B, C, E, H. So H is there only, as B, C, E already have been used. Is it okay? So we will add H here, and E is processed. Sorry, F is processed. Now what we will do? Which will be removed?
E.
E. So remaining are G, H, and for E, the adjacent vertices are B, C, D, F, G. B, C, D, F, G.
F
Anything
will be
F will be added. F already processed,
yes sir, yes sir.
so we
Sir,
will not
H
add.
will not be. We will not add.
G.
So we will not
G.
add anything now. So E is there, processed element. Now, which element will be removed?
G will
G
be
और
removed.
H ही रह गए. G.
So here only H is there, and process is G.
G.
Now
So
G के
why are we
neighbor.
removing F first then E?
Sorry,
Sir, why are we removing F first then E?
F, because we have which element is entered first in Q.
F.
So F will be
Okay.
removed first. It is first in, first out. If I entered in the order EF, then E will be removed first.
Okay. So sir, we can enter in any order. So whatever order we enter, we have to exit in that order only.
Definitely, we need to follow the Q rule. Okay, remove G and its neighbor, add its neighbor. Yeah, Nachi, actually add its neighbors to rear. Yeah, Nachi, actually. Everything I need to add over there now. So G, what are the neighbors of G? D, C, E, H. Already all have been processed. So no
हाँ तो
element
H
is
ही
there.
बचा है.
Now what element is there now?
H.
So we will remove H.
Yes.
And now it is,
Empty. Null.
and it is processed. Now that is the final order of traversal actually. So you can see the traversal order of this graph. BFS traversal order of this graph will be A, B, C, D, F, E, G, and H. Is there any doubt? It is quite easy actually. Is there any doubt? Tell me fast.
No sir.
Everyone, it is okay.
Yes, sir.
Now look at that. That why it is called breadth first search. You know, this graph. Look at that graph. We have started from A. We have started from A, and then we have visited B, C, D at the same level. That is what the breadth-wise exploitation of this graph. Then F, E, G at the same level, and then finally H at the next level. That is what the breadth-wise traversal of the graph. You are understanding it? Label wise, we are traversing the graph. That is why it is called breadth first search. हमने breadth में पहले explore किया, then we are moving on to the next and then the next and so on. So mostly all the nodes of that particular level will be traversed. Almost all the nodes. I am using word almost. I am not saying exactly all the nodes, because in some cases it may also possible कि we may move on to the next level before completing the nodes at the previous level. But it will be rare actually. It may be possible in the directed graph. Okay, but it will not be possible in the undirected graph actually. So directed graph के केस में कई बार ऐसा होगा कि मान लो यहाँ पर एज ही नहीं हो, उसके एडजेसेंट होगा ही नहीं सी, मान लीजिए, तो सी से हम नीचे वाले लेवल पे आ सकते हैं. बट मोस्टली आई कैन से 90% वी कैन से इट विल बी एट द ब्रेथ वाइज सर्च. Breath wise we are exploring the nodes. So is it okay to you all now? In BFS, if you have any doubt, you can ask. So I am now going to write an algorithm for this. So that is easy actually. We are writing that one. We can see that all the nodes can be in 3 states while it is being processed. First state, before entering into the queue. Okay, first state is before entering into the queue, second state when the element is in the queue, and third state will be when the element is out of the queue. So based on these three situations, I am having that a node could be in the three state when the node is not visited at all. Second one could be the waiting state when the node is in this is inserted into the queue, but it is not processed yet. Process नहीं हुई है, अभी process होने के लिए wait कर रही है. Is it okay? Process होने के लिए wait कर रही है. Like in this case, you can see कि D, F, E, G are all in the state 2. Okay, because C now at that point C is processed. तो ये state 3 में है, ये सारी states 2 में है, और H I can say it is in state 1 right now because ये अभी तक queue में आया ही नहीं है. Okay, and third state will be process state when the node is removed from the queue and processed. Process मतलब वो write हो गई है या whatever it is traverse हो गई है. Now based on that I can write the algorithm for this, and that could be initializing all the nodes with the ready state, that is state number 1. All the nodes of that particular graph will be initiated with the state number 1. Then put a starting node, it could be any, in a queue and change its states to the waiting state. Like हमने A को यहाँ put किया and उसकी state change करी state 1 से 2 पे. Then we need to repeat the step number 5 and 6 till the queue is empty. We remove the front node from the queue, that is say n. N को हमने remove किया मान लीजिए, and then process n, उसको process किया. ये सब हम कर चुके हैं. Okay, like here we have removed A, processed it, and then we have entered the adjacent of A to the queue. Process it and change the status of n to the process, that is status number 3, and add all the adjacent of that node n to the rear of the queue and change their status to 2 because they were previously they were into the 1 status. And then we will repeat the step. Okay, and in this way it is done, and we will get the BFS of the graph A, B, C, D, E, F, G, H. Is it okay to all now?
Sir, in breadth for search, we are traverse for nearest element because breadth चौड़ाई.
Nearest adjacent elements. You can say adjacent element.
Yes, sir.
Yes, anybody wants to ask anything? No question at all? I am going to take attendance. So we have learned about breadth first search, one traversing of the graph. Okay, and before that we have seen the representation, linked representation of the graph also. In next lecture we will see about the depth first search, the next traversal of the graph. How depth first search will work, which data set it will use, and how the elements will be processed, we will see. And then we will also start a minimum spanning tree algorithms for the graph. Is it okay?
Oh,
So that is all from my side, and now I'm going to end this meeting.